Hello everyone, I'm Paul and today we're solving problem 790, domino and tromino tiling. This is a medium problem, but this can be tricky, especially if you have never seen this before. So keep watching for my intuition, approach and efficient solution. We are given an input n which represents the width of a board, and the height for every board is fixed at 2. So our job is to find the number of possible ways to fill the board with domino and tromino tiles. So in this example, for n equals 3, we have 1, 2, 3, 4, 5 ways to fill the board. So the answer is 5. Now let's see how can we solve this. Let's say we have a board with a fixed height of 2 and n could be up to 1000. Now the key for this is we need to keep track of previous states. And to keep track of previous states, we can use dynamic programming. And we'll think about this as if we have an I pointer here, and if we are trying to iterate this board, trying to fill every space up to n. Okay? So let's suppose the I pointer is here. Now the question is, how many ways do we have to fill this first column? Now let's think about this. For example, we can use a domino like this and update I, and the previous column will be full. So we can update I to I plus 1 and the previous column will be full. So we can put true here. Now we have another way to fill this column. Let's say we put 2 dominoes here, one here and another one here. We are filling this column. So in this case, we would update I 2 spaces and the last column would be full. So I plus 2 and the previous one is true. Now what else can we use to fill this first column? Well, we could use a tromino like this, and in this case we would need to update I 2 spaces up to here, and we will have a space in the previous column, so previous will be false because of this space. And finally, to fill this column we can use a tromino like this and update I 2 spaces, and we will have a gap here. So I plus 2 and the previous column is false. Now these are the only 4 ways to fill a column when the previous column is already full. Now let's see how can we fill a column when the previous column is not full. Let's say this is our current state. I is here and the previous column is not full. So what can we do here? Well, we could use a tromino here and update I 1 step. So here the previous column will be full. So I plus 1 and previous equals true. Or we could use a domino here, update I 1 step, and by doing this we'll have a gap here. So this would be I plus 1 and previous equals false. And these are all the possible cases when the previous column is full and when the previous column is not full, when it has a gap. And now we can recursively add all these scenarios, and if we reach n, meaning I equals n, and the previous column is true, we can add 1 to our result. This is the entire approach, and the solution will require a time and space complexity of big O of n because we are caching previous results. So now let's go with the code and hopefully you will get the idea. First we'll say mod equals 10 to the power of 9 plus 7, and we'll create our function solve. This will take 2 arguments, an index, and a boolean to know if the previous column was full or not. So previous full. And finally, we want to return a call to this function with an index of 0 and true for the previous column. And we will mod this by the required value. Now let's see what are our base cases here. If I is greater than n, well, in this case we are out of the board, we are out of bounds, so we need to return 0. And if I equals n, meaning we are right at the end of the board, well, in this case, if the previous column is full, we want to return 1, else we return 0. And next, let's say the previous column is full, or we are starting with this. Well, in this case, we want to return solve I plus 1, true for the previous column, plus solve I plus 2, true, plus 2 times solve I plus 2, false. And if the previous column is not full, if not previous full, in this case we want to return solve I plus 1, true, plus solve I plus 1, false. Now this is almost the entire code, but we want to avoid repeated work here, meaning if we call this solve function with the same index and the same boolean for previous full, we want to instantly return the result that we already got in the past, so we can cache every return value. So now this is the entire code, and we'll submit this and see if it works. And as you can see, this works. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.